Morning to doctor and my friends. My name is Sudarshan, son of Sukumaran. My metric number is DE190074. Today I will explain the working principle of our simulation and I will conclude the overall of our project.
Hi doctor, my name is Tinishan Ryan Analaki Tyagarajan. My metric number will be DE190062 and I will be explaining on how and why we carried out the simulation and on the discussion.
Good morning, doctor, and to all my friends. My name is Vignesh Chan. My metric number is DE19003. Today, I give you a task for my circuit simulation. I will show you about the calculation and the simulation. I use nodal analysis to do the calculation. I apply KCL and Ohm's law in my calculation. Once I finish my calculation, I do my simulation, and the result is same like my calculation.
Hi, today I'm going to show you how to calculate using nodal analysis. First of all, we need to read the question carefully. Find the value of Vs that will cause the 2 ohm resistance to conduct a current of 3 ampere following downwards. Okay, first of all, we need to know what is nodal. Okay, nodal is I equal V higher minus V lower over R, and nodal is about KCL. Before we do calculation, we need to do two things, that is, observe the circuit carefully and label what we need in the circuit. There are three things that I observe. First of all, I observe that this circuit given one independent current source, and the second that I observe is my reference node is V equals 0. Okay, then the third one that I observe is there is only two nodes that given in this circuit, and I label as VA and VB. Then I label the current flow for this circuit. Then the last one that we know is the following current from these 2 ohm is 3 ampere. After we already observe, we already label, now I'm going to show you how to calculate using nodal analysis. Let's see how. Okay, let's move to the calculation. In my calculation, I apply Ohm's law and KCL to find my Vs. Okay, what is Ohm's law? Ohm's law is V IR, and the formula of Ohm's law is V equal IR and I equal V over R. Okay, we already know the formula. Now let's apply the formula on my calculation. So I apply Ohm's law to my VB and I get 6 volt. Then I apply KCL to my VB, I get 2 ampere. How? I1 plus 1 equal 3. The 1 is from the independent current source, the 3 is from the following current. Now let's see. We know that VA and the VB are cross current. So VA and VB is current leaving equal current entering. Then I get 6 volt. Then I apply Ohm's law to my I2, so I get 3 ampere. Then I apply KCL to my VA, I get 5 ampere. As we know, the current flowing to 2 ohms is 5. Then we apply Ohm's law at V1, so I get 5 volts. Then the last of my answer, Vs, I get 17 volts.
Hi, today I will show you and explain about a circuit simulation. Before this, I use nodal analysis to do my calculation. I apply KCL and Ohm's law in my calculation. Today, I will show you one component that I use for my circuit simulation. I use DC emitter, ground, resistor, voltage source, and current source to run my circuit. I apply KCL to each of the non-reference node. We know that V equal to 0. And I apply Ohm's law to express the branch current in the terms of node voltage. We know that nodal analysis is equal to I V higher minus V lower over R. We know that the current passing through VA and VB depends on the voltage and the resistor in the branch. So now I'm going to run the simulation. After I run, I get VA equal to 12 volt, VB equal to 6 volt, and my voltage source Vs remains 17 volt. That's all from me.
Now I will explain the working principle of our simulation. Nodal voltage analysis uses the nodal equation of Kirchhoff's first law to find the voltage potentials around the circuit. So by adding together all these nodal voltages, the net result will be equal to 0. Then if there is n nodes in the circuit, there will be n minus 1 independent nodal equations. At each node point, we write down Kirchhoff's first law equation, that is, the current entering a node are exactly equal in value to the current leaving the node. Then we express each current in terms of voltage across the branches. For n node, one node will be used as the reference node, and all the other voltages will be referenced or measured with respect to this common node.
I hope we have all understood what my both friends have explained. And now what I'm going to say about this simulation is what we what is this simulation is about and what are the process we took. Okay, let me tell you about the simulation process. Simulation analysis intends to verify that the product meet its requirement for operation. It can further provide insight into necessary changes and validate that the correct real-world tests are conducted. It simply means a test that we need to carry out in real life, physically, before bringing to the testing field. We do it in experimental way first. That is what we simply call simulation analysis. Okay, there are few steps that we took into account before doing this simulation, which is these are the main steps you have to follow before conducting a simulation. Step number 1, we have to decide on the purpose of the simulation and what performance metrics we want to monitor. For our case, we are going to measure on the value of the Vs, of the voltage source. Number 2, we have to build our simulation. That means we got to make sure all the components is correct. All the components are in its right place, no minor errors to be found. Third, we got to calibrate our simulations. That means we make sure all the values of the component, for example, resistor with 1 ohm value has to be in 1 ohm value, the current source ampere, the voltage source voltage, all that we have to take into account. We have to make sure nothing goes wrong. We have to set the value and the limits right. And the last step will be we analyze the results and select the best alternative result. We analyze and we select the best. In our case, what we did was we had 3 attempts. We carried out 3 attempts. That means we run the simulation 3 times and then we chose the average or we chose the best. That's how we carried out this simulation. And now we are going to look at discussion. Okay, from this given assignment, we have observed and decided to solve it using the nodal analysis. Why nodal analysis? Because nodal analysis is used to determine node voltages by solving KCL equations for the incoming and outgoing currents at each node. Thus, to satisfy the value of Vs, which caused the 2 ohm resistor to conduct a current of 3 ampere. As what we have learned and practiced, no matter it is a mesh or nodal analysis, as long we have a question with a circuit, we have to number 1, observe, number 2, label, number 3, redraw. Now we have a circuit with an independent current and voltage source. So now we have to assign the reference node or known as the ground. Next, label names to the remaining nodes and then solve the easy nodes, as now for us we are solving VB first. We got the KCL for the node and the I1. By using the KCL outcome from VB, we are now finding I2 and VA by using Ohm's law. Now we are applying KCL to node at VA to find our I3 flowing at the 1 ohm resistor and also the voltage by using Ohm's law. Therefore, now we have found all our labels to get the value of voltage source, Vs. And the flow to the voltage source, which is sum of VA and V1 is equal to 17 volt. That means Vs is equals to 17 volt. Besides that, to show that the calculation we carried out proves the requirement of the value of Vs that will make a current of 3 ampere flow downwards causing by the 2 ohm resistor were being shown by the aid of simulation using the circuit maker application. Thank you.
Thank you, Tinshan. I will conclude overall of our project and simulation. We had construct the circuit correctly and successfully run our simulation. Finally, we had learned how a nodal analysis works and how to determine the voltage at each node relative to the reference node.